Sir Collins, I have a question.
Sweet. It looks like for the most part, we're kind of deftly avoiding the trap I set. In what way did I try to trick you in this problem?
You gave us the value of the hypotenuse, but not one of the sides.
Yeah, I would actually say there's two. That's one of them. I tried to first confuse by just spinning the triangle. So that sometimes gets some people, but you're absolutely right. I did not provide you the A and B value. I provided you the A and C value. So just as we kind of said before, the A and B doesn't necessarily matter, but it does matter relative to the C value. The C value must always be the largest side, therefore must be the side that's added to, hence on the right-hand side of the equals. So in terms of solving, all that really means is we're solving for B, and B is just a different place in the equation. It doesn't change what we do whatsoever. So that'll be 100, that'll be B squared, that will be whatever 26 squared is. What is 26 squared? So we have a calculator handy.
It's 676.
Thank you. Okay, and so that'll leave us with B squared is equal to 576. Okay, and so B would have to equal 24. Okay, and so looking at the chat that, everyone kind of agrees. So it looks like we're pretty adept at solving this type of problem. Does 24 make intuitive sense to the problem? Is that a reasonable answer?
Yeah.
Please explain.
It's smaller than the hypotenuse.
Okay. And as the hypotenuse has to be the largest one, certainly has to fit there. And also the secondary reason being the numbers are relatively close to one another. I'm totally with that. If I wanted to check this, how could I check this answer for sure? Because we're kind of convincing ourselves that it seems reasonable, but how would I check it?
You would do what you did in the other problem to see if you got 26 again.
Mm-hmm. No, absolutely. So this is this is every other algebra problem, excuse me. We can simply resubstitute to see if the equation matches to begin with. No, I'm totally with you. Okay.
Mr. Collins, what are you dividing by?
I'm not dividing, that's the square root.
Oh, yeah.
No worries. Okay, one last question, then we'll move on. When I take the square root of an answer, it actually produces two values. So if I take the square root of 76, the answer is 24, but what's the other answer?
Negative 24.
Okay, yeah, because when you take a number times itself, two negatives certainly make a positive, so we have to consider that case. Now, in neither one of these answers, though, we consider the negative case. Can someone give me a reason why we would just ignore that case? Or ignore the answer?
You can't really square root a negative number.
Yeah, we can't do that. No, that's for sure. But we're not square rooting a negative. We are square rooting a positive 576. What I'm saying is if you take the square root of a number, so if we took the square root of 25, that would actually produce two answers, 5 and negative 5. But for our first example, we just ignored the negative. We never discussed it. If I take the square root of 576, it would be both 24 and square root of 24. 24 and negative 24. Why would we just ignore the negative?
Because the sides can't be written in negative if the rest are positive.
Absolutely, that's a perfect reason. So in terms of finding distance, we have to make sure our answer seems reasonable. And part of the reasonableness is how it fits with the other numbers. But part of the reasonableness is also going to be, does it fit the problem itself? Right, since we're dealing with the side length of a triangle, we can't very well call that side negative. What are the questions you guys have about Pythagorean theorem before we move on to the rest of our discussion today? Great. So I think this is going to serve as a good basis for our work. So today we have to talk about a couple things. So guys, I know like most of our class so far has been just like us jamming notes at you. That is not the intent of every single day. It's just really for this first unit. There's just so much information we have to cover. This is the most efficient way to do it. Okay, and so this will be your last set of notes for this unit. Because keep in mind tomorrow, which is the day we're not going to meet over Zoom, is designed to kind of be like a review day. And remember, you're taking your first assessment on Thursday. Okay. So this note template is in Schoology as normal. Otherwise, let's take maybe 3-4 minutes, cool your brains down, get your notes set up, and then we'll reconvene and have this discussion. Thank you. That's your thing right now. Otherwise, it's simply preparing your notes. 9:23 is when we'll start. Okay, so For our last conversation of this topic, it's going to be a fairly calculation-heavy day, but it should be also a very straightforward day. And so the big thing that we're talking about is talking about how to calculate the midpoint and distance. Now, as a side note, I'm talking with your algebra teachers, depending on your school and your teacher, some of this may be review. Okay? I think you're going to see like a common thread from the opener all the way through. But I do acknowledge some of you guys may already be experts in this. But either way, we want to give you a sense of how this really ties into the bigger picture. And of course, specifically what you're going to have to know and be responsible for showing us, how to do. Okay, so big guiding question today: how do I calculate the midpoint distance of a given segment on or off the coordinate axis? Really quick point of order. When I say coordinate axis, what precisely am I talking about? Just so we all know. It's a term you certainly have heard before, coordinate axis.
The XY.
Thank you. Yes, absolutely. Thank you, Zach. So when we're talking about the coordinate axis, we're just talking about like your very standard like XY grid. And again, just as a point of order before we get started, if I take a coordinate, which is just like a point on the grid, which comes first, the X or the Y?
The X.
X.
Absolutely. So it's going to just be XY. I know that's really easy, but it's also a very easy mistake. And so just in case you had some rust on that because you haven't done that in like 6 months, I just want to make sure you know. In terms of like these other terms, excuse me, when we talk about the midpoint, what are we most likely talking about? Even if you didn't know, just intuitively. Yeah, it's going to be just the middle. Of course, distance is going to be some kind of length. Okay. And so all we're talking about is how do you find the middle of something and how do you calculate how long something is. That's all we're going to be doing today. All right. So first big question. Okay. This is kind of a weird question to lead off with, but this is like the guiding thought of our whole thing. The reason we talk about midpoint or distance is because we're really trying to figure out how to cut something in half in geometry. This terminology has already been exposed. Like, what do you call the thing that cuts something in half? I'm thinking about yesterday. Yeah, we got it. So it's going to be bisector. So remember, when we're talking about a bisector, we're just talking about the act of cutting something in half. And so if I say bisect, I mean cut in half. And so really the question is really, how do you know that we bisected something in geometry? Okay. And I would claim there's a couple different ways to know that. Like, for example, if we take, say, like a segment, okay, call it NC segment. And let's say I intend to cut this thing in half, okay, with point A. We kind of had a discussion yesterday about where to place point A, but I'm trying to place point A right in the middle this time because I am trying to bisect it. Okay? But there's no way I did this perfectly. There just isn't. And so, like, how would I know that I intended to cut this in half? What would I have to add to the diagram to show my intention?
Could you put the congruent lines on segment NA and segment AC?
I sure could. And so remember, it doesn't matter how many tick marks we have, it just has to be a matching set. And so like this is our baseline, right? So how can you tell you cut something in half in geometry? Well, it could be given. Okay, and remember the term given in geometry is a very powerful one. It means like if it was there by the person who wrote the problem, you can trust that it's true. And so if you have this diagram with these tick marks, right, and just for the sake of like solving mathematics, let's say this was 3x plus 1, and this distance was 2x minus 6. Knowing that you have the tick marks, knowing that A is a bisector, okay, what kind of equation could I write to help represent this? And so if we notice the structure is bisected, we know the relationship of bisection, what would the equation look like?
3x plus 1 equals 2x minus 6.
Brava. Okay, and then we solve all the way down and we get what? Like x is equal to -7. I made that problem up on the fly. Don't actually try to go back and resub that. This is just like an example. Okay, and so like that's our baseline. If we want to know if something's been cut in half, well, if we're told it's cut in half, we can just use that information. We can set up the bisecting equation, solve for x, and go about our merry way. Okay. But what if we're not told that? So what if we have a situation where we're not given the congruency marks? We don't know that we have a bisecting point or a midpoint or something. How can you tell then? Okay. With the kind of the side note, so I'm going to present a couple different ways to tell if something's actually been cut in half, but we're going to have to use a different environment. And so one option I think is if we calculate the distances. Okay, and so I'm going to use the example above just to kind of, actually, let me drop this down a little bit. Can I go this far? Is that okay? Good. Okay, and so like I said, we're going to have to change the environment a little bit. Oh. Okay, so if we're not just given the information in like on the segment itself, we're going to have to put the segment on a place so we can do some calculations. In this case, on this coordinate axis, so this coordinate grid. If we're going to put a line on a coordinate grid, the very first thing we should do is probably label it. Okay. And so let's just call this point A. Really quickly, can someone call it the coordinates to A?
-6, 3.
Very good. Because if we started at 0, we can move left 1, 2, 3, 4, 5, 6, and then up 1, 2, 3. Remember, left and right is going to be your x distance, and then up and down is going to be your y distance. So if we call this point B, again, coordinates really quickly, please.
-2.
1, 2, 3, 4, 5, 6, -2, totally with that. Okay, and then we should have some point kind of in the middle-ish, which I'm just going to refer to as point M. Point M has coordinates, but I'm going to keep them variable. So the proper way to say what I just wrote is that point M would have the coordinates x sub M and y sub M. The term I just used was sub, S-U-B. It's a shortened version of the word subscript. And so whenever you have like a small number written like below a variable or below a letter, it's called a subscript. Now, I kind of estimated where that should go, right? I'm saying, again, I'm not entirely sure where it is. And although we're on a grid and we can maybe be a little bit closer to scale, I'm just kind of guessing that's where M should go. Okay, but in terms of like actually calculating it, we should kind of identify our target first. What has got to be true about the distance AM and the distance MB if M is truly the midpoint?
They have to be equal.
I'm totally with that. So if AM is the same as MB, then M is the midpoint. Okay, so this is going to kind of be our working statement. Okay, so if the distance AM is equal to the distance MB, Then M is both the midpoint and also bisects AB. These terms, midpoint and bisect, are not exactly synonymous, but they're very closely related. Okay. Now, those of you guys taking notes by hand, maybe even on your own paper, I know your grid is not going to be perfect. Okay. That's not a huge deal. In fact, I don't know if I'd even really draw anything but the axes. The important part, I think, are going to be the coordinates. And so as you're taking notes, making sure that you get this down, and then your picture kind of looks close to what you're seeing on the board, I think is going to be the important part. Okay, so I know some of you guys are going to try to draw every single grid. I wouldn't do that. If you're just taking notes by hand, I just focus on the axes, the X and Y axes, and then the picture the best you can. All right. So now that we have kind of like the table set, we have to figure out how we're going to actually calculate some distances, because the if part means that we have to actually show the AM distance and the BM distance and then calculate that, or compare them, excuse me. So we have several different ways we can do it, but one way you'll be responsible for knowing is by something called the distance formula. Okay, now this doesn't often happen with me, but I'm just going to directly give you this formula. Okay, and here's how this goes. Oh, not you. So to calculate the distance D, you can take the square root of, big square root, I will totally explain that formula. But let's get it down first. I'm sorry. Okay, so let's talk about the pieces. I know this looks very, very intimidating if you've never seen the distance formula or operated before. There's a bunch of subscripts going on with like these 1s and 2s, but let me kind of explain what's going on. So first of all, just kind of take some notes here. X1, Y1, and X2, Y2. Okay, these are the coordinates of the endpoints themselves. Okay. So in this case, the 1 and the 2 are simply in order. So 1 is like the first endpoint, the 2 is like the second endpoint. And so in this particular example, X1, Y1 just refer to A. So like X1 is equal to -6, Y1 is just equal to 3. And so that's going to give us numbers to substitute in this equation. Okay. Replicating the thinking, X2, Y2, that just refers to the second set of points. And so X2 and Y2. So like X2 is 6, Y2 is going to be -2. And so they're just giving us numbers to kind of like substitute into this equation. Places where you'll make mistakes on this equation, by far, the biggest mistake I see has to do with the negatives in the calculation, along with squaring a value. Okay. We'll see an example. We're going to come back and attack this problem as well. Okay. But the thing I want you to pay close attention to, especially if this is the first time you operating the distance formula, is how we handle the parentheses and how we handle the square value. As you guys are catching up, really quickly, if you square a value, like if you take any number and then you square it, is it possible for that number to be negative? Yes or no?
Yes.
Okay, can you explain how? Like, how do you take what number when squared becomes negative? Whoever said yes. I don't know who just said yes, but can someone give me an example of a number that when you square it stays negative or becomes negative? Okay. Rephrase the question. Is it possible to square a number and it be negative at the end?
No,
Why not?
because a negative times a negative equals a positive, and the only way to get a negative number is a negative times a positive.
There it is. So I'd like you to hang that idea in your head, because like that's the precise mistake some people will make, particularly with their calculators. Okay. I'm going to come back to this, but I want to push forward with an example. Okay. So the question here is M actually the point of bisection? In other words, is M the midpoint? Well, using our notes from the previous question, M is going to be the midpoint of JK if and only if two distances turn out to be the same. If JM is the same as MK. And so that's what we have to calculate. We have to calculate JM, we have to calculate MK, and we have to compare the two. So let's calculate this one first.
We didn't get the entire part of like above it. Can't really see the answer to the question.
Okay, I can read the question off. I don't know if like that, I have like a ribbon that's blocking mine. But all it says is that M is the midpoint of JK if and only if the two distances are the same. Okay, because remember, JM and MK, these are all distances. And so we're just going to check if the distance to the midpoint is the same for both. Okay, which means we're going to be operating the distance formula twice. Okay, so as you're kind of catching up and sketching the picture, I'm just going to write the distance formula down. I know a lot of people are catching up. Can you guys just like give me a thumbs up or a hands up? That will tell me I can proceed. And if you're doing electronically, just like leave it up. I'm sorry?
What was the little sentence at the top?
M is a midpoint of JK if and only if JM is equal to MK.
Thank you.
You're welcome. And so like the gist of it is we're just checking two distances, and we're going to check to see if they're the same. Okay. So if this is like your first time ever operating the distance formula, knowing there's so much going on, I would strongly suggest doing a little bit of just organization first. And so like the thing I would do is to make sure I was really clear on what my x2, x1, y1, y2 was. So I'm going to do a little labeling here. I'm going to make this x1, y1. And I'm going to make this x2, y2. Keep in mind the 1 and the 2 just mean like what your endpoints are or what the 2 points are for your distance. It doesn't really matter. No, that's a great question.
No.
It doesn't really matter. I can easily call M x1, y1, and I can call J x2, y2. Because we're finding distance, the order doesn't tend to matter. And you also said, or someone actually said earlier, that if it turns out to be negative, we're going to square it anyway. And so that negative goes away. Okay, now it's just a substitution problem. So still a big square root. So x2 minus x1. Well, here's my x2. Here's my x1. And here's where you got to be super careful with your parentheses. So x2 is -1, so I'll write that in. Now, the formula itself has a negative. We see a minus sign here, and so I have to use that. Regardless if my next substitution has one, which it does, -5. And so there is going to be a double negative here. You guys know how to handle it. We're going to handle it in the next step, but during substitution, we want to make sure we're representing everything. Okay, same thing with y2 minus y1. Y2 is going to be 2. Got it right here. Minus from the problem itself. And then y1 is going to be -3. So again, I have a double negative, and I'll square it. Notice my use of parentheses. That forces my order of operations. That means I have to resolve what's in the parentheses first, and then square the result. Okay. Now, you can definitely grab your calculator, but I think we should be able to do this in our heads. If I have -1 and subtract off -5, what's the value?
-6.
So -1 subtract -5 is not going to be -6.
4.
It's going to be +4 or -4.
Positive.
It's going to be +4, yeah. I'm not quite sure who answered first, but I'm going to give you kind of an alternative way to think about it. I tend to get confused if I see a bunch of like signs like this. I don't know if anybody's like me, but I also know I can like intuitively look at -5 and -1. If I'm subtracting it, I'm really just trying to tell how far away they are. And so the big question is, how far is -5 from -1? Like if I was traveling from -5 to -1, how far of a travel is that? Okay, and I hope we can agree that's going to be 4. Direction doesn't necessarily matter there, but it's going to be overall travel of 4. Let's do the same calculation here. So we have 2 subtract -3. What value will that give us?
Positive.
5.
Be 5. Remember, we're still going to square it. And again, I would offer that if I start at -3 and I end up at 2, that's an overall travel of 5 units. All right, because -3, -2, -1, 0, 1, 2, that's going to be 5 away. Okay. But either way, we can just continue with our simplification. Square root's
I
going
thought
to
it'd
come.
be -1.
I'm sorry?
Instead of 5, I thought it'd be -1 since the 2 is not a negative.
So we have 2 subtract the -3. 2 negatives, can we agree, make a positive?
And so essentially you'd have 2 plus 3 equals 5.
Exactly. The same thing happened on the previous one. So I had -1 subtract the -5. 2 negatives become a positive. -1 plus 5 gave us that 4. Okay, so let's resolve the squares. Now I have to mention this because someone will try to do this eventually, and so let's just like kill this idea now. I know you guys see a square root. I know you guys see these squares, and at least one person throughout the course of the day is going to be like, oh, squares and square roots cancel. I can just cancel all that. Okay, I'm not going to give you like a big long-winded explanation, but that absolutely does not happen here because we're adding those things together. Which means we have to square those numbers and then add them together and then take the square root last, which is what our order of operations demands anyway. What is 4 squared?
16.
Okay, what is 5 squared?
25.
Okay, so the distance between J and M is defined to be the square root of 16 plus 25, which would be what, like 41? Okay, I know that number is not going to be a whole number because it's no number times itself. No whole number times itself is going to make 41. Can you guys go to your calculators, whether it be your phone or whatever you're using? And can you guys please give me the square root of 41 out to 3 decimals? The thousands place.
6.403.
Okay, so 41. Can someone independently confirm? I heard 6.403. Can someone confirm that?
Correct.
Confirmed.
I have
I'm
that.
sorry. Okay, so 2 people confirm it. Can I get one more confirmation? The square root of 41 is?
Yeah.
Okay. Now, we do have to round this. So 6.403. Does anyone know the proper sign to put here? Because it's no longer an equal sign. I'm just curious. Does anybody know?
So
It's an
wiggly.
equal or negative, or
Yeah.
equal or subtract.
Yep. Okay, so like that little symbol I put there, that wavy equals, that means it's approximate. That means I'm intentionally rounding it. It's no longer perfect. It's been rounded. But guys, that's the distance formula. That's the whole thing. And so certainly you can see the places where we can mess up because we had those errors kind of in that discussion. So my advice to you, be really careful on your substitution. Make sure you know exactly what goes in for your x2, x1, y1, y2. Make sure you watch your negatives. Make sure your calculation's clean. Before we move on to check the other length, together at least, what questions do you have about the use of the distance formula for this question? Okay, so we know this length is approximately 6.403, which means n is a midpoint only if this distance is as well. And so that means now we have to check MK. Okay, so if you haven't moved on and to try that yourself, can you try that right now? I'm going to give you 90 seconds. Can you please use the distance formula, calculate the distance of MK? Just in case you forgot the distance formula, there it is again. So 90 seconds starting now. See if you can confirm that M is indeed the midpoint.
Mr. Collins, if you're talking, we can't hear you.
Well, I'm not talking. I'm just following my own instructions. I'm also finding the distance. The answer is currently on the board. So please check your work against mine, and I'll take questions here in just a minute. Okay, and so this is an example of what your work could definitely look like. What questions do you guys have about the process of using distance formula with either of the two examples? Okay, then I have some questions for you. Did anybody notice a weird thing I did with the distance formula? Both distance formulas. I'm wondering if anybody picked up on it.
You flip the exit x 2 and x1 and the y1 and y2.
I sure did, and that's a common question that distance formula users ask eventually. Should it be x2 minus x1, or should it be x1 minus x2? What does this example answer that question? Or how does this example? What about this example answer that question? Does the order
fact
matter?
that they both got the same answer means that it doesn't matter.
Yeah, no, absolutely it does not. Because in the end, what you're really doing is calculating a difference. If that difference turns out to be negative or a difference turns out to be positive, their absolute values are going to be the same. And once you square the value, it's going to be positive no matter what. So what I mean by that, if you would have switched these two numbers and had -1 minus 3, you would end up with -4. But once you square it, you still have 16. If you would have switched the 2 and the 7, you would end up with -5. But again, when you square it, you're going to still end up with 25. Okay? So once you're using the distance formula, the order doesn't matter whatsoever. Second thing, I don't think I really had to go any farther than this to prove it. Someone explain why. Or really, I guess I didn't have to go any farther than this. I could have stopped right here, I think.
Because the
Because
equation is the same on both sides from that point.
Yeah, and so like we can use like mathematical intuition or mathematical like logic. Like once the equations look exactly the same, I know the results will be exactly the same, and so technically I could have stopped there too. Okay, so just a couple points of order. Last thing I want to emphasize is like I told some people last week that this wasn't algebra, it's geometry, and so I'm showing you all the steps for the benefit of those who've never used a distance formula or might be struggling a little bit. But you don't necessarily have to use all the steps either. Really. Here to here is a fine jump for us. It's fine. Okay? As long as you're getting the answer correct, I don't mind you jumping. Okay. Questions before we move on? All right. So in this analysis, I'd be remiss if I didn't ask this question then. Does anybody see a different way to calculate the distances that may be a little less algebraically intensive than the distance formula?
Count the squares on the line.
I'm sorry, the what?
On the grid. Count the segments on the grid.
What do you mean? Okay, I'm back here to the grid. I'll try to demonstrate what you're talking about, but could you explain?
So like you mark every square that it like goes through, and then if it's the same on both sides, then it would be the same distance.
You're talking about this little trick that I see students try to pull. So like this. And
Yeah.
trying to count. Okay, I like what you're trying to do. Whoever's saying that, is that you, Nick? I like what you're trying to do, but here's the problem. How far have you gone if you've gone from here to here? Like how far is that?
A square.
Okay, but here's the problem. It's not, that's not the same square, quote unquote square, as from here to here. Because they're hitting different parts of the grid. And so if you zoom in, look at that, the pink one starts and ends in a different place than the dark blue one I drew. And that is a different one than that one. And that's a different length than this one. And that's a different length than this one. if you're going to count, you have to count by something consistent. Okay? And so you can't really count diagonally on the grid. I mean, I'm not rejecting the idea of counting. I just don't think you can count in that way. Could you count a different way?
Mr. Collins, could you go back to the question? I didn't get it all.
The question just is there a different way to do it other than calculating the distance? Like calculating the distance, well and good. You're going to have to show you can do that. But like smart mathematicians will always look for alternatives, and I'm giving you guys the opportunity to try to generate alternatives. And so if we want to get the distance between J and M, is there another way to do it other than do the distance formula? Does anybody see an alternative?
Measure it with the ruler.
So we run into the same problem with what we did before. Measurement's a very imprecise thing. Okay, had this been a normal year, we would actually started the year measuring stuff, and then we would have promptly destroyed it as a precise tool. Because if you think about a ruler, it shifts around. You have to kind of line up the marks, which means it counts on your eye. I like the idea. I'm not trying to shoot down a ball of fire or anything, but I don't think measuring is going to do the job either. I do like the idea of counting, though. The thing that Nick brought up, I think it was Nick. He tried to count, but he tried to count kind of like in this direction, and the grid is not equipped to count in that direction. But could we still use counting as a way of determining distance? The teacher says, obviously hinting that we can. So we could reform the question. In what way could we count the distance between J and M?
So could you count like, I guess, or like go over and then up?
Okay, direct me towards it. You can't see, but my pen's at J. Okay, so count me over to M. Tell me what to do.
Sorry, I was muted. So you go to the right 5.
1, 2, 3, 4, maybe?
Sorry, yeah, only 4, yeah.
Okay,
And then
so
you
that's 4.
go up until you meet M.
Okay, now you may remember this from middle school as a slope triangle, because what Evelyn just did was tell us a change in X, and then also report out the change in Y. Recall that this delta symbol, why did I quote that? Means change in. Now that counting doesn't tell us a distance. What you did is a form of what we call taxi cab geometry, like you're going from you're taking streets from like one house to the next house. And although that tells us like the distance you traveled, that doesn't actually tell us the distance in between. But everyone take a look at the board right now. If I wanted to get the distance between J and M, what could I do?
Solve for the hypotenuse.
Yeah, can we just use this guy? Like, wouldn't that just be as good as using the distance formula? What would the A value be?
5.
Okay, or 4. It doesn't really matter which, right? So I can just pick one or the other. I already had the color queued up for this one, so I'm going to use that. Okay, and then the B value would be, what, 5?
5.
And that would equal C squared. So that would be 16 plus 25 is equal to C squared. 16 plus 25 is 41. That would equal C squared. And then how would I get this? How would I get rid of the square again?
Square it.
Square root it, right?
Do we have to take notes on this, or is this just showing another way that you can do it?
Oh, I would probably guess like that you should probably take some notes. Yeah. I mean, your notes are always your own. Whoever, I don't know who asked that question, but I would say your notes are always your own. And the note should be a record of class, but also be a record of things that made you like, maybe didn't think of initially. And so, so with complete honesty, I'm trying to get you guys to make a connection between what we started the day with and what we're doing right now. If you're seeing that connection, you may not need to take notes over it. What connection am I trying to get you guys to see?
Can you
Hypotenuse.
Yeah. I mean, so like, let me ask the question more directly. Is what we did any different than the distance formula?
Not really.
I don't think
Just
so at
different.
all. I mean, look at the calculation. Didn't we end up with the square root of 4 squared plus 5 squared? Isn't that literally what that is? And so you have an alternative here in terms of how you want to attack this. You can certainly use the distance formula. Or the Pythagorean theorem. In fact, if we wanted to find the secondary distances, we can again draw on our triangle. That's just changing x again, and that's going to be 4. This is going to be this is going to be the change in y. That's still going to be 5. Okay. And again, we could set up the Pythagorean theorem. But since we have the same values we're substituting in again, it's going to turn out the same way. I don't remember what the decimal value is. That's why I wrote it like that. So I'll pop up back up here in a second. But the answer to this question is yes. Oh. All their alternatives. Yep. And that the big alternative is going to be the Pythagorean theorem. Okay, so we have the distance we can take directly using distance formula. It seems like we can also cut this up into triangles, and we can use the Pythagorean theorem to also find those distances. But I'm curious, does anybody see yet another alternative? Particularly if you think about this drawing. Outside the distance formula, outside the Pythagorean theorem, is there another way that we could have confirmed that -1, 2 was indeed the midpoint?
They were both over 4 up 5.
Explain.
Like whenever you were getting the x and then the y, they were both the same.
The change in x and change in y?
Yeah.
Yeah, okay, so can someone explain that a different way? I don't mind the way Zach explained that, but I like to hear it from like different perspectives. Someone explain what Zach's talking about.
If the change in x and change in y is the same, that would mean that the distance is also the same.
Okay, so change in y and change in x to the midpoint and to the next are the same is also going to be the midpoint. What if, so like, I like that idea, but like, what if we didn't know where the midpoint was? Like go back to page 1 real quick.
You could find the distance between point A and point B and then split that in half.
Yeah, I like that idea, but here's a problem though. If I knew the entire distance being split in half, I still wouldn't know how far to go. I can't count diagonally. Okay, but I do like the idea of like this change in x, change in y business. If I'm going from A to B and traveling only the ways I can count, what is my total change in x here? Count it out or calculate it out. What's my total change in x?
$12.
Okay. And we can also calculate that, right? Because we're going from -6 to 6. That's going to be 12. What's my total change in y?
5.
Up 5 or down 5?
Down.
Okay, so it's going to be
-5.
Yeah. And so to go from A to B, so to go from endpoint to endpoint, I got to go over 12 down 5. So $1 million question to see if you're catching on to what I'm trying to get you to catch on to. Tell me how to start at A and end up at the midpoint then.
Divide both x and y by 2.
Okay, so tell me how far to go. If I'm going to start right here at A and I want to end up at the midpoint, how far do I go to the right?
6.
Okay, so 1, 2, 3, 4, 5, 6. And how far do I go down?
2.5.
That's going to be 1, 2, and then a half. Oh, look at that. There's a line there. And that means the potential midpoint is going to be 0, 0.5, 0, half. Does that look correct to you? Like if you had to put money on it, would you put money that this is probably right?
Yeah.
Yeah, I think I would too. And so it seems to way like you have now devised a third way, or 2.5. Another way to find if you have been bisected. And so you can certainly use the distance formula to calculate the distance, or you can use the Pythagorean theorem to calculate the distance. But also it seems that we can calculate this midpoint. And you guys did a wonderful job extracting really what the midpoint is. Okay. The midpoint is nothing more than the halfway point of travel from one endpoint to the other endpoint in the component directions. Okay. In other words, the midpoint understands that you can't count or move diagonally on a grid. You can only move left and right and up and down. And so just for the record, that's what I mean by components. So I'm going to pause a moment so you guys can catch up, because I know there's a lot of stuff to write down right now. Okay, just for the sake of tying all the symbols together, that symbol I just put there that looks like a triangle is usually pronounced delta. It's actually the Greek letter D, which stands for gradient. That doesn't necessarily matter, but when you see that little triangle, it's delta. And so delta x, delta y mean the change in x, change in y. That's just for your knowledge moving forward. Okay? In terms of finding this, you guys have 100% uncovered the counting method. I would say this is probably going to be the intuitive way to find the midpoint, especially if you have a grid. This is probably the way I do it more often than not. And I think it was Zach. I don't know who said it. It might have been Zach or maybe someone else. But yeah, we just counted halfway in between. That's all we did. Okay. I'm going to come back to this, guys. Just hold on. Let me just demonstrate again. Okay, and so if we know the whole delta x travel, change in x travel is going to be 12. We just got to go half that distance. And if we know the whole delta y travel is -5, we just got to go half that distance. And so if we go over 6, down 2.5, we can get that midpoint 0.5. That's all we did. We just went half and half. Okay. There is another way to do it, and it has to do with a direct calculation. And so this is well and good if you have a grid. What happens if you don't have a grid, or maybe you just don't trust your counting skills, or like you just prefer the calculation itself? Well, the big thing is that we're just going to find the halfway point, okay? Or the middle point, right? And so the mathematical question to pose is, how do you calculate the halfway point between numbers? What's that even called if you want like the middle point between a set of numbers?
The median?
Close. The median is actually the middle of a big set of numbers, but not necessarily the halfway point. It's one of those. It's one of those words, though.
It's a mean.
Louder, please.
It's a mean.
I can't. I'm sorry. I can't quite hear you. Your mic's so super soft.
It's a mean.
Did you say? I think you said mean. I think I heard the answer. Is average. Another term for average is the mean. Because you have mean, median, mode. Median and mode are something a little bit different. Mean is actually the average. In terms of finding the average, how do you do that? Like you have a bunch of numbers and you want to find the average, what do you do?
You add them all up and then divide them by the amount of numbers there are.
Yeah, and so you add and then divide, in this case by the number of numbers that you have. Okay, so let's devise a formula then. If you want to find the x and the y of the midpoint, and again, we're using subscripts here, so that's x to the midpoint and then y to the midpoint. You said we're going to take our numbers and add them together. Well, we're going to still keep them in different components. And so we'll add the two x's together. And then what should we divide by? 2. Because it's literally two numbers. And we can do it separately with the y value. So y1 plus y2 over 2. Knowing that we're adding, does it matter if you write this as x1 plus x2 or x2 plus x1?
No.
Not at all. And so however you want to write that is completely up to you. What is important is that you notice that the x and the y are kept completely separate. Okay. And so the x calculation just has to do with the x's. The y calculation just has to do with the y's. Okay. So I think either, to be honest, are completely, either the two methods are equally the same in terms of difficulty. But if we come back up here to this example, and I'll go back down in a second if you didn't finish copying that down. Oops. Okay. If I want to find the midpoint, I take the two x numbers, add them together. Well, I have 6 and -6 divided by 2. Then I take the two y values, add them together. And divide by 2. Okay. Now I will say, like, although it doesn't matter if you write it as x1, x2, y1, y2, you got to keep the order consistent for both the x and y calculation. Okay. But if we have -6 plus 6, that's going to be 0 divided by 2. 3 minus 2 is 1 divided by 2. And if you run that calculation out, no surprise, it's going to be 0 and 0.5, which we already knew because we counted it. So let me zoom out. So in terms of finding midpoint, we have a couple different ways. One, we can execute a count and determine where the middle point is. Otherwise, we can execute a calculation. Again, the formula looks super complicated, but it's really just averaging. Add the two endpoints together, divide by 2. Add the two endpoints together, divide by 2. So in terms of midpoint and the midpoint formula, what questions do you guys have for us? Cool. All right, let's move on. So these are just some examples. Okay. So now that we can kind of do that with a grid and we have alternatives, of course the question turns to, well, can you do it without a grid? So like, for example, using both the distance formula and the midpoint formula. Actually, let me change this up. Yeah, let's go ahead and do this one. So let's confirm that the segment AB has been bisected by the point M if we have these 3 points. Now, we don't have a grid, but we can still produce a picture. And that would be my advice. Although the picture is not going to be perfect, okay. We can still get some kind of visual about where they all line up. And then we can set the task to actually find some distances. Now, if we're going to confirm that M is indeed the bisection point, which is also the midpoint, we do have 2 ways we can address it. One, we can confirm the distances, right, by simply finding the distances. Alternatively, we could also find the midpoint. We should probably practice both. Okay. So let's first set the task by finding AM. Okay. And we should also find MB. And also calculate the midpoint. Okay, in an effort to kind of work together on this, can I get anybody with a last name ending in A, B, C, or D? Can you calculate the first distance, AM? If your last name begins with an E through L, can you calculate the second distance? And then everybody else calculate the midpoint. Okay, so A through D, calculate the first distance. E through L, let's calculate the second distance. And then everybody else calculate the midpoint. And then we can compare answers. Once you have your answer, can you throw it in the chat so people can double check their work too?
How do you tell which line, which like point for X and Y is X1 and Y1 or X2 and Y2?
It actually doesn't matter. You just got to stay consistent. And so if you call A X1, Y1, you have to call B X2, Y2. Or if you're calculating the middle ones, if you call, wow, what was that? Okay, if you call A X1, Y1, you got to call M X2, Y2. But you could flip those.
Thanks.
You're welcome. $16 divided by 2 is 8. Negative 9 divided by 2. Okay, it looks like we're getting some people confirming it. I also put it on the board. I just worked them out too. And so it seems like we have many different ways we can attack this. And that's really the bottom line. I do want to kind of point out one thing on my work right here. Okay. Since we've said many different times that it doesn't really matter like which one you call X1, Y1, which one you call X2, Y2, we should acknowledge that when you subtract those numbers, you're really just looking for a distance. And so another form of the distance formula is really just using the change in X and change in Y. Here's what I'm talking about. We're going from 4 to 8. Well, if I go 4 minus 8 or 8 minus 4, there's not really a difference. But what I really am calculating is how far away the two numbers are, hence change in X. Like literally on the graph, like that's what we did. We did a change in X value by going back and forth. And so so you can use that as a shorthand for the distance formula as well. And so it doesn't concern me if you write it out long form, you use a short form. What I'm concerned with is that you can calculate the distance to be 8.5, right? So here's the deal, guys. We have run out of time, right? There is one more set of examples that I wanted you guys to work through, but I'll simply like ask you to finish that in your notes, or finish your notes. I'm sorry. So if you go to Schoology, like the last page of notes and the template's there, and we'll have these examples on it. This example is very straightforward. I didn't even plan on calculating it out with you guys. And so like the last question is, well, what if you're not trying to confirm things are in the middle? Can you just use so can you just like use a distance formula and the midpoint formula to find a distance or midpoint? Well, yeah, of course you can. And so a typical question that you'll see is something like this. Find the midpoint distance if these are the endpoints. And so you just feed into the formula. And so that's going to be like the pedantic kind of common question. This is kind of the weird curveball. And so again, I'd like you to download this and like finish this, and then I'll finish the notes on video and post them in today's folder so you can double check your work. But like this is like the one they think is super tricky, but it's not tricky at all. What they're saying is that A is an endpoint, and then there's like another endpoint down here somewhere, and they want you to find where this endpoint is if you know that M is a middle. But I bet you guys can already guess how to do that. You can certainly simply count it out, but you can also use a formula to calculate it out. Guys, don't do that. I realize you can do that, but please erase that. Let's remember like we're in school, and let's not be disrespectful, please. Okay, and so you can also calculate it out. So for like your work today, I'd like you to do a couple different things. Okay, one, like finish those notes, and again, here is like the actual like template you can download so you can get all the examples. This is just practice, and really you can consider this like part of the review going into your test on Thursday. And again, the key is provided, and then you have like another essentially a review assignment with the key provided. Okay, so those are going to be the three things I'm going to ask you to do tonight and also tomorrow. Tomorrow we're going to add like an actual like review, but again, it's going to be no different. It's going to be a bunch of problems that we're going to ask you to solve. Okay, and please notice nothing here is turn-inable, and so this is just practice on your own in preparation for your test on Thursday. Okay, so in review, one, finish your notes, and we're going to put out some kind of video.
Mr. Collins, we can't really hear you right now.
Is that any better?
It's good
Can you guys
now.
hear me? Okay, thanks. So like just in review, one, finish your notes. Two, work on this practice. Tomorrow, remember, we're not Zooming at normal time. It's just like work time all day. Office hours 2 to 4, but again, there's going to be stuff in review for the review stuff. Because Thursday, when you come back, that's going to be our test day. Okay? And so we're going to ask you to log in at normal time, and then we'll go over the test procedures then. Questions for us? Okay, guys, that's all we have. Let's see, Anna says, do you think there'd be more midpoint answers? Well, there can only be one midpoint. And so for any given segment, Anna, there's only one point that goes to the middle.
I'm surprised more people didn't answer for mid.
Oh, I got you what you're saying. Well, we can't force people to type into the chat. So that's why I also provided the answers on the board. Okay. Plus, you were kind of already given the midpoint anyway. And so it was really just an issue of confirming it.
Mr. Collins, for the practice work, does that need to be turned in, or do we just do it on our own?
It's just practice on your own. Like, just consider study material for the test.
Okay.